All right, so we've got a function f that's continuous on the closed interval between -3 and 3, such that f of -3 is 4 and f of 3 is 1. F prime and f double prime have the properties given in the table below. So basically this table is giving us properties of f prime and f double prime. Before we even start this, let's just kind of think about what this could mean. So right here in this interval between -3 and -1, it's telling me that f prime is positive. So what could you tell me about f? It's increasing. The fact that f prime is positive means that f is increasing. The fact that f double prime is positive means that f is concave up. Good. All right, over here from between x equal -1 and +1, f prime is negative. So what's f doing? Decreasing. And since the second derivative is positive, then f is concave up. And then in this little section between, or the interval between x equals 1 and 3, f is decreasing and concave down. Good. So we've actually answered a lot of the questions that it's going to ask on this. However, we're going to start off with what are the x coordinates of all the absolute maximum and minimum points of f of x on the interval between -3 and 3. Now, absolute extrema can occur at one of two places. Where can absolute extrema occur? Endpoints and critical points or relative extrema. All right, now an absolute minimum will either occur at a relative min or at an endpoint. So I'm going to start with that. So the absolute min is either going to occur at a relative minimum or at an endpoint. What would I need to look for in this information to identify a relative minimum? Okay, where f prime of x is 0. That's a starting point. Does that guarantee a relative min?
No.
Okay, f double prime would also have to be positive. What if I was just looking at the f prime row? What would I be looking for with f prime to find a minimum of f? Right, f prime is changing from negative to positive. Is there a point where f prime is changing from negative to positive? No. All right. So I don't have a relative minimum, so my absolute minimum would have to be at an endpoint. And then an absolute extrema, I'm literally just comparing the y values of the endpoints and the critical points. So do I know the y values of my endpoints? Yes. So at what x value, up here, at what x value does my absolute minimum occur? X equals 3, right, because it asks for the x value. So the absolute min is at x equal 3. Now, your justification for this, and you pretty much always have to justify all of these answers, is I need to summarize what we just talked about. So there was no relative minimum because f prime doesn't change positive to negative. Sorry, negative to positive. So then the other thing I have to consider were my endpoints. Well, why did you pick x equal 3 as opposed to x equal -3? That's smaller. How can I communicate that mathematically? Okay. How about f of 3 is smaller than f of -3? All right, so my absolute minimum is x equal 3 because there was no relative minimum, and f of 3 is less than f of -3. All right, then my absolute maximum. An absolute maximum will occur at a relative maximum or at an endpoint. Do I have a relative maximum? Yes. Where is that relative maximum? X equals -1. And we know that because f prime is changing from positive to negative. Okay, so I do have an I have a relative maximum, and I have endpoints. So how can I use this information to determine what the absolute max is? I don't know the y values except for the endpoint, so I don't have any way of determining the y value of that relative max. Think about what your function f is doing. At your beginning endpoint of x equal negative 3, where is f going to go from x equals negative 3? Up. Until I hit x equal negative 1. And then what is f going to do? It's going to go down. And then what's it going to do? Go down some more. So where's the absolute maximum? It's at x equal negative 3. Anytime, I'm sorry, it's at x equals negative 1. Sorry. Just making sure y'all are paying attention. Sorry. My pen's jumping around too. Okay, sorry. So at x equals negative 1. Now, anytime you only have one relative extrema on an interval, if that relative extrema is a maximum, that's going to be the absolute max. And if it's a minimum, it's going to be the absolute minimum. So anytime there's only one relative extrema, you know that that's going to have to be an absolute. And just, I mean, it's common sense when you start thinking about it. So your justification here is because x equal negative 1 is the only relative extrema, and f prime of x changes positive to negative, so that's how we know that it's an absolute maximum. And really, on this problem, notice that part A is the only part of this problem that doesn't ask you to justify, but I wanted you to think through this, and I wanted you to have this written down so that when you go back and look at it, you will know how we got these answers. Okay, hold off on the fact that at x equal negative 1, the derivative fails to exist. The f of negative 1 does exist because it tells us that f is continuous on that closed interval, but for some reason that derivative doesn't exist, and if you haven't figured out why, you'll figure it out in just a second. All right, B. Where is for what values of x is the graph of f increasing? Okay. From x equals negative 3 to negative 1. Now, how do I justify my answer? Why did you pick that? Because f prime of x is greater than 0. So you have to justify in terms of something that was given to you in the original problem. All right, for what values of x is the graph of f decreasing? Okay, negative 1 to 1 and 1 to 3. Can I just say from negative 1 to 3? No. No, I can't. Very good. Now, the reasoning is because f prime of x is less than 0. At x equal 1, what can you tell me about f prime? It equals 0. F can only decrease when f prime is less than 0. So that's why I have to break up that interval between negative 1 and 1 and then 1 to 3. I cannot include x equal 1 because f prime equals 0 at that point. I don't think, you don't have to put the union between the two. It's down there at the bottom, sorry. Okay, for what values of x is the graph of f concave up? Okay, so what am I looking for in the table? Where what's positive? Double prime, right. Please do not ever use the word it, because we're talking about way too many different things here. All right, so that would be between negative 3 and negative 1, and also between negative 1 and positive 1. And that's because f double prime of x is greater than 0. And for the same reason that we just talked about, you need to break it up into the two intervals, because at x equal negative 1, the second derivative doesn't exist, so it can't be positive. Okay, so for what values of x is the graph of f concave down, then I'm looking for where f double prime is negative, so that's between 1 and 3, because f double prime of x is less than 0. All right, f is the challenging one in my opinion. What are the x coordinates of all the points of inflection on f of x between the interval from negative 3 to 3? Justify your answer. Actually, on this problem, it's not as challenging. Never mind. Okay, x equals negative 1. You are correct. Why? Actually, no, you're not correct. It's x equals 1, right. Why is x equal 1 a point of inflection? F double prime does equal 0, but f double prime also, or it fails to exist at x equal negative 1. F double prime equaling 0 is not justification for a point of inflection. Yeah, because f double prime of x changes signs. Your definition of a point of inflection is where the graph of f changes concavity. And so therefore, f double prime must be changing signs, because f double prime positive means f is concave up, and f double prime negative means f is concave down. So it's conceivable that you could have a place where f double prime equals 0 or is undefined, but on either side, the graph is both concave up or both concave down. So f double prime has to be changing signs. Okay, and then on part G, sketch a graph that satisfies the given properties of f. So the first thing that I would do is I would put in those given points, those given endpoints. And I'm told that f of negative 3 equals 4. And I'm told that f of 3 equals 1. All right, the next thing that I would probably do is try and put in my extrema. So I know that I have a maximum at, what, x equals negative 1? Now, I don't know anything about the y value of that maximum, but if I have a relative maximum at x equals negative 1, then I know that that has to be a hill in this graph. So I've got to go up from my starting point. And then I don't have any relative minimums, but I had my absolute minimum, which I already have over here on my graph. So I know that my graph is going to increase, my graph of f is going to increase, and then it's got to come back down and decrease. But I also need to take into consideration the concavity. Where my point of inflection is at x equals 1, and I don't know the y value, so I can just draw, I can put in a point of inflection at any point that I want. But I know that at that point of inflection at x equals 1, how is my concavity changing? Am I changing from concave up to down or down to up? Right, concave up to concave down. All right, now the other thing I can do is I can just look at that graph, look at that table from negative 3 to negative 1, and since f prime, actually go back and look at this slide that I wrote up here. This little segment between x equal negative 3 and negative 1, my graph needs to be increasing and concave up. So if I draw increasing and concave up, it would look something like that. Y'all cool with that? Okay, the next segment between negative 1 and positive 1 is decreasing and concave what? Also up. So it needs to look like this. And then the last segment is decreasing and concave down. So it looks like that. Now that I've drawn this graph, does it make sense that the derivative at x equal negative 1 does not exist? Yes, it's a cusp. All right.